Right. So I think the streaming attempt was a bit failure. This is after 2 weeks. So there's some thinking that I did about how do I go about solving problems and making sure that I kind of remember them. And there are like a couple of schools of thoughts, and main one is basically using Anki somehow. Uh, I'm not sure exactly how I can do that because it's a bit difficult. So when I see a question like this, okay, to Sam, there's a couple of things that is happening. One, it will have specific outputs and inputs. So I need to like devise an algorithm that gives me these outputs and inputs. So like that is like some information that I can remember. Or I can remember the algorithm itself, which can be used in some other question, right? And that sounds much more realistic to memorize. Because if I'm gonna memorize something, I want to memorize something which is not so rigid or like so unique that it can only be used for like one idea, like two sums itself. I should have like cards that are much more what's the word? Like you can more interactive somehow. So okay. So here's the idea. Okay, give yourself 30 minutes to solve a problem. Now, 30 minutes is because that's the industry standard for any interview, I think. You'll only get 30 to 15 minutes. The faster is better. But obviously, I think if I spend more than 30 minutes, I can fall into the loop of spending 3 hours into one problem, which is just not efficient. I might as well just like learn about the problem, right? Instead of trying to break my head on it. Although I feel like if I do break my head on it, it will help me memorize it better. But not memorize it, like learn it better. But I think I need to if we wanna see how many problems I have done, uh, yeah, I'm very behind. I need this number to be at least 300 uh by the end of which month? Actually, let me see. Let's have a notepad. Is it capturing? It's capturing. Okay. So by the end of October. No, that's too soon. I have 15 days then. Fuck, it's 15th of October. Okay. By December. Okay, so that's 2.5 months. That's 60 plus 15, 75 days. 35 days. And I want about 300 problems solved. I think that's like a bit too high. So let's do 75 into 2, 150 into 3. So like 4 problems a day will give me this much. Yeah, if I can do it, but obviously that's a bit too high. 300 problems is nice. I think I can cover most of neat code by then. I'm sorry if the light is like a bit too annoying. Let me see if I can. Okay, this is a bit more paler. Okay, let's see. 300 problems solved. Fine. Okay, so basically I have to spend 2 hours a day solving the problem. If I fail, Ankifying the solution and retrying it on the Anki day. So like as if you don't know, the Anki, the way it works is that it spaces out the amount of time you need to remember an item, basically like a flashcard. And what this does is that it kind of it works better than rote memorization, where you just kind of cramp a lot of flashcards in a very short amount of time. This is like a spaced repetition program where the more space you have between remembering or like recalling an item, the more likely you are to remember it for a long term. Okay. Okay, this is a bit tough. The issue is that I'll probably fail most of these problems the first time. So in reality, I'll be doing this at least 1200 times, right? Hmm. It's just not realistic. You know what? I'm thinking too much. I'm thinking too much. Okay, we'll just think of one problem. Problem 30 minutes. Then 10 minutes Ankification. 10 minutes. So what do I Ankify here? That's the thing, right? So let's just try to solve 2 7 30 minutes and then let's see the solution. And then let's see if we can extract an Anki information from it. Okay. Alright. So fine. Let me add a timer so that we all can keep track. Um, use mini mode. Can you see it? 1 second. Uh, okay. This kind of looks nice. Let me just increase the size so this looks a bit more fun. Ooh, perfect. Oh shit, I didn't enter a typo. Okay, so I updated stream info and I have my timer here, and let's just do some DSA, do some practice. Okay, so I have 30 minutes to do this, so let me just start and try to think about it. Okay, so given an array of integers nums, an integer target, return the indices of the two numbers such that they add up to the target. So if I have a array of 1, 2, 3, 4, 5, 6, and I have a target of 10, then I need to return not 4 and 6, I need to return the indices, which is like 0, 1, 2, 3, 3 and 5. So it will be array of 3 and 5. Okay, fine. And let's just see the. Okay, I can return the answer in any order. Okay. Can you come up with a way to make the algorithm less than O of n square? Okay, complexity. Fine. So there is no space constraint. So what we can do is we can use a hash map, and hash map is an additional space where I'm basically mapping the array of nums into a hash into a map, which is like which is more easily accessible due to its indexing. So it will allow me to kind of escape this n square loop issue. Okay, so let's just do that. So for const number of nums, and let's make a const hash map new map if my hash map has number. Okay, wait, does this have duplicates? You may return the same element twice, so it might have duplicates. Okay, so if that's the case, I just need to map it if it doesn't have duplicates. Okay, so then map set hash map set uh, number indices. No, let's just do index. And let's actually make a loop because I think that feels it very easier to have index. So for let I is equals to 0, I is less than nums length. I always forget if it's th or ht in length. I think in American it's ht, I'm not sure. Anyway, so we have an index here I, and we'll have nums I. Gonna copy this and gonna paste it here. So now we're basically creating a hash map with index nums, and it's storing the index which is there in the array, and we're gonna create a new array. Once result is new array, we don't need to define its space. I think we can maybe do it too, because why not? Oh, you know what? Let's not. There's no need. Um. Okay. So basically, if there's an array, I'm just gonna find its first values. So this is the array. So now the hash map will be 2 index 1. 7, 11, 15, and I'll have index 0, 2, 3. Okay. So this is my hash map now with the array. Okay. Now for now we need to loop over the hash map itself. So we can loop over with map. There's a hash map high order array which is for each. It's called a high order filter function. High order function. I totally forgot. You know what? But it's fine. So, but I do remember that the first thing is value, and then that is the key. And what we need to do is we need to check. Okay. So how do I do this? You know what? I think instead of assigning this as num I, what I need to do is I need to kind of subtract. So, okay, here's the thinking, right? So, if I have the target as 9, and instead of storing like this, what if I store it like as target, where I do t minus 2, where the t is the target and 2 is the actual value of the array. In that case, I get the value of 7. So when I loop over the array, I'll try to see if target 7 exists in the array or it exists in the map. If it does, then I'll return the indexes 1 and 2. Okay, that sounds fine. So let me just do comma target. Uh, okay, for each value, if value dot target. Okay, so now here what I try to do is I try to find target if it exists in the map. So if, for example, target here is 7, I'll see if it exists here. Then I'll try to return both this index and this index. So here I'm pushing value or index, which is the actual value. So basically where I found a target. Okay, and I'm also gonna push uh, again. Now I have to find that map, right? So hash map get value or target. Then I need to find its index. Okay, so here I'm trying to find this index in this and then just targets index here. You know what? Yeah. Okay. Okay, so now here is like few things. I need to quit after I find the first match. Also, I need to make sure that it survives every scrutiny. Okay. Okay, okay. Because I've done this problem before, so I can remember that there is few caveats. For example, this code will not work for this solution. And that is because when I'm trying to target, it can also check its own index. So for example, here, right, it's 3, 2, 4. So here, my 3 target is 3, right? Because it's 6 minus 3. And 3 exists in the thing, but it cannot be itself, right? Because it cannot be the own number. You may not use the same solution twice. Yeah. So how do I escape this condition? First things first. And then how do I escape this condition? Where it should be 0 and 1. So it should be the next target. Okay. So what I can do is I can add a condition here and condition. I can be like condition value dot index. Okay, so here I'm gonna this is a bit more for formatting, but you can actually have it inside itself. But now we're gonna just see if, for example, hash map has the value target. Okay. Now what we need to do is we need to make sure that value index is not equal to hash value index. Okay. I cannot have the target as this thing. Yeah, so the issue again in this example is that my map itself, right, it's storing in a number value as indexes. So maybe what I should do is I should make it so that it's value, and these are two. Then maybe I don't need an uh, array itself. Oh, can I just do it with now with just the nums array itself? Because if I'm using the indexes, hmm, this is a bit tricky. The issue in this one is that both the value and target is common. If I use the indexes, I'm kind of faulting into O n square, where I need to kind of loop over the entire map and see if it works. Hmm, interesting. Let me think about this a bit second, okay? I need to do something with this else condition to satisfy this thing. Because otherwise, I'm kind of escaping the O(n) square. Okay, so let's just see if I can still make it work where this is still the index. And this is the structure of our map still. So let's just think about it. So if condition is false, no, but then how do I store both of these without the indexes? I have to store it. Hmm. I need to store this as index. Unfortunately, then it does not make sense. I have 15 more minutes. Should I give up or think a bit more? I think I should think a bit more. I think my main issue right now is that how do I store it in the hash map? The information, especially if the information is duplicated. The issue if it's duplicated is that they'll have different indices, but they'll have the same target minus nums and as well as same value if you're using as an index. And our index should be a unique value. Hmm. Uh, One thought that is coming is that if it is such, then I can add another additional value here, where it's like dupes, which is like a boolean. So it's like false. Else, or it should be the int. So it will be an integer. So it will be, oh, it cannot be zero. Okay, let's say -1. Dupes is equals to I. So here I'm gonna store both the indexes if it's a duplicate. And here I'll first check if this is a valid condition or not. So if hashmap has value target, okay, now we assume the target is there. What we can do is that we can see if the index is same, then we'll check value dot dupes. Okay, you know what? This is a bit confusing. Let me just finish formatting it and kind of walk you through what I'm trying to do here. I think there might be a simpler way, to be honest. But let's just see if this kind of follows. Okay, so I have my hash map, all right, and I'm trying to assign the array to it. And the array can have there's two properties to be known. So it can have duplicates, and the answer should not be a duplicate with quotation marks. So essentially, if the target here, for example, if the target here is 6, okay, the answer cannot be 0 and 0. It should be two different indices, okay? So our output should not have duplicates. At the same time, our input can have duplicates, all right? So input can have duplicates, answer or output should not have any dupes. Okay, fine. If this is our condition, now let's just see. We have a simple array and we have a hash map. For each value of the array, we check if the value exists in the hash map. If it does not, then we assign it as the main value as its index and have these as our properties. So we'll have a normal dupes is equals to -1. Okay. Now because if, for example, we get into a duplicate scenario where it is actually a duplicate, we'll actually assign the index of the duplicate value here. And we'll keep on updating it. So it's like, even if the last duplicate, it's fine. It doesn't matter. All right. So now our hash map is a bit more descriptive. It also kind of tracks where is the duplicate, the target value, and it has its index. And so this will allow us to do two things. So with the target, we can have an O of 0 complexity when trying to find the second index for the two sum, because we need to do it at less than 1 square. So that's our reasoning for having nums as I, or like the actual value of the array as our indexes. If the idea is that simple, is that target minus any of these values should give our one more value here if it's there. If it's not, then when what should we return? You can assume that each input will have exactly one solution. So we don't have to consider if there is no solution such as that. So there has to be one solution. Fine. Now, now let's loop over this nice map. We'll have, yeah, I'm just gonna keep it like this. Okay, so if the hash map has the value target, so we find 7. Okay, fine. If we find 7, then we just check if the value index, so our original values index, and a hash map get value target dot index. It's not the same. And if it is, if it's same, and if the value is not -1, then we actually return this as value dot dupes. Else, if else. I think it's else if, not bad. Um, okay, this is getting a bit too complicated, so I'm pretty sure this is not the answer, but fuck it, I just want to run it, and I only have 8 minutes, and I'm pretty sure there will be some bugs here, so let me just kind of use the last two brain cells I have left and try to think about this. Okay, if the value is our current number, index is same as hash map, get value target, so if it's like the same target or index, if so, and the dupes is not -1, then we return loops. Okay. Else, we want to do nothing, and it's this. Else if this is a very, very badly structured code. I'll be honest. Uh, this loop should not exist like this. I should do it in a reverse manner. So first I should actually target this and then target this and then essentially this should be not be a case at all. But I can't think of the reason right now. So I just see and we'll have our test cases from here. So we'll have this case. It's always nice when you're using lead code to make sure you use all examples because these examples are really nice. They cover a lot of the scenarios. Not all of them. There might still be a test condition that will just give you an error, and that would be only be able to be found once you submit, which is like the sad part. Unless you have the pro version, I think, where you can see the test cases when you're using submit. So let's just run code, and I think it would be a wrong code. Oh, okay. First, let's just comment our shitty code. Okay. If a mouse only wants to work, submit. Okay. So here's a nice condition where our loop didn't escape. So it actually found the targets and then it found a target again. So we need to break our loop somehow. That's one thing. Okay, do we have 5 minutes? Can we figure out how do I break the for loop? Yeah, you can see I tried to do this 3 months ago, but I absolutely do not remember what was the answer. And I think I had a help with my friend, so it doesn't really count. So I'm trying to do it on my own. Huh. Let's just see JavaScript for each break out. How do you break out? Hmm. I feel this is a bit too complicated. Let's think about this a bit more. Hmm. I mean, I think this is a cheating, but I guess it might work. So yeah, let's just see if this works. Okay. You know what? This is a bit tricky. Basically, we just kind of ignoring that our loop is duplicating, and we just kind of creating a condition where if it actually becomes more than two, because it's two sums, so we know that there can only be two indices. We just escape by returning the result here. I think it might still fail in submit. So let's just try submitting. And it was accepted. Okay, guys, 28 minutes. You know what? Terrible code, I feel. Let's just see how did it do in our performance. Okay, so matter of fact, this is the best performing code I've written. uh, yeah. Okay, fine. Now let's just try to do the fun part. How do I code this method into an Anki file? Okay. Hmm. You know what, guys? I think this is time to do the classic, the age-old research. Let's just do it incognito, so we have a bit more. Is incognito being captured? No, it's not. Um, mm, wait, libraries, properties. Okay. Uh, let's just see google.com, accept all, Anki. So now we're kind of researching how other people have tackled this problem, where they want to create an Anki deck for like algorithms. Let's just give it some time. So we'll do Anki uh, trying to figure out DSA. Okay. Huh. Okay, so they have done things like that, where they have small snippets of code where they want to do something very quick, which is where to reverse an array and all that stuff. That's kind of fun. So, mm, yeah, maybe we can break down our code into like sections where we have like a small section where we do things like putting an array into a map and try to track its progress. Hmm, not sure. Let's see neat code IO and practice. Heading to some. Close. Let's do JavaScript. Okay, so this is how neat code has done do some. It's a bit more long, but I feel okay. I think it's not that long. I think it's because they have done it twice. So this is O of n complexity, and this is n square complexity. Hmm. You know what? It's actually a bit difficult to kind of figure out a way to encode a DSA problem into an Anki file. Like, how would I remember to some if it's like 2 years ago? What are the main things that kind of speak out of to some? So, where is our? Hmm. Okay. Huh. So this is a chunk, and this is our main thinking order. Okay. The central idea of do sum is that uh we need to store value of n, where n is the value of target minus, oh sorry, let's just call it m. We just stored m, target minus value of n. So this is basically the idea is that if it's do sum, by the logic kind of pertains that if this is a candidate for the two sum, the value of m must also exist in the array for it to be true, right? Because m plus n is equals to target. Yeah, so like if it's like n plus m is equals to target. So this kind of makes sense where m is equals to target minus n, right? So this is the general idea of two sum. Hmm. And then everything else is a bit on the question itself. So there's like two more constraints here, which is kind of unique, very important to kind of remember. One is that the element may not be used twice, but it can exist twice. So the input can have duplicates, but output must not. Input can have duplicates, but the output must not. So this is the essential part of TUSA. If you have this, I think you can figure out an algorithm nonetheless, right? So, but is this the best way we can kind of just encapsulate the idea of TUSA? Well, let's just see Neat Code's program. By the way, guys, you just check out Neat Code. He is really amazing when it comes to teaching, and I think the Neat Code practice view is the best question bank you can kind of prepare for, and it's what I'm aiming to. If you remember, I had a discussion at the start of the stream where my target was to finish 300 programs by the end of December, and it's mainly because of the Neat Code, like Neat Code questions. So, TwoSum is again a very popular one. So, yeah, let's just do like this. Yeah, do some JavaScript. Okay, so let's just see the codes he has done, and let's just see if our information we kind of captured here does it work out there. Okay, so for the first brute force problem, where the time complexity is O of n square and the space complexity is O of 1, so this is kind of nice because he's not using any additional space, but unfortunately suffering in time. What he does is just creates a normal loop over nums. Okay, he creates a complement. Nums is equals to minus. So this is again the idea of m is equals to target minus n. So this is again this kind of like seeing this code and seeing NeetCode's code kind of like reinforces that this is a very key part of solving this problem. That this is an actual like a good key point for the do sum problem, right? So that's there. So the complement, I think that's a nice term for it. So let's just think about that. Okay, fine. So he has one loop, complement, and then he just loops over the nums and he just checks the next value. Okay, curve press one. Okay. Um, uh, Now my question is that if he's running the second loop with curve plus one, so if you're like in the middle of the loop, do you ignore the previous values? I guess that makes sense, right? Because like if the previous value was the contention, it would automatically would have been solved in the first go. So what I mean to say is that if, for example, my loop is starting from here, 7, okay, and my second loop is from 11, 15, so on and so forth. I'm not considering 2 because the loop starts from 2. So if 2 was the real value, then we would have already scanned all these values. Let me just rephrase that. I think that was very confusing. Essentially, there's two loops going on, okay? One loop that starts from the first index, so it's like 0 to 0, 1, 2, 3. And then there is a second loop which starts 0 plus 1. So it starts from 7, 11, 15. So 1, 2, 3. So if this is our main target value, no, not target value, this is our, let's just say the pointer, the main pointer. We use the second pointer to find the value in the remaining set of the arrays. So if this has a sum or like a complement which exists here, it would have been found in the first loop itself, right? So that's why we don't need to really consider the loops behind. Uh, okay, this is a nice solution. So this again reinforces this idea, and the output's not duplicate. Yeah, because we're just kind of looping through it. It just doesn't care about it. So that's fine. Cool. Now let's just see the two buses hash map. Okay. So so I think this is the entire code. Okay, so to sum map get map nums. Okay, and then return get sum nums target map. Okay, so what does get map do? Get map is a simple loop where we have an index which we index the nums value and we create a map inside the function itself. And this is a bit more you're kind of gonna show off your skills to the interviewer. I like this a lot, but it doesn't really matter. And what we're trying to do is we just trying to kind of achieve our value here, where we just try to have nums and we have the index. So this guy's not really caring about the complement right now. That is fine, I guess. So this just creates a map of all the values of nums and their indexes. Okay, fine, that's cool. And then get sum. What we do is we loop over nums. Okay. You know what this thing does, which is very unique? If there is duplicate, it just updates the index. You know what? That's actually pretty smart. Instead of doing this loop where we're trying to see if there is a duplicate and we add a duplicate, we just keep on updating the index, so on and so forth. So we can remove the dupes part and we can simply have hash map set the value of nums and we can just loop over it. Okay, that's smart. And then we calculate the complement on each loop itself. Hmm. And the idea is same. If the complement is there, then yeah, we just return it. Yep, this is a bit more smarter. Essentially, we're just updating the values of dupes instead of tracking both dupes ka value. It's smart, I feel. And we return minus minus if nothing is the case. That's true. Now, my issue is that with the value of 3, 3, won't this just have a single entry of 3 is to 1? Oh, you know what they're doing? They're summing up. So, our operations, if you see here, is actually with the map and the map itself. But what NeetCode has done, which is pretty smart, is that he's still considering the nums array. Because this is again a data structure that we still have access to. And we simply trying to iterate that structure array and see if the map exists. This is pretty smart. So this way, the duplicate, the value of 3, 3 is still being captured because we are tracking the index from the nums array and the sum index from the map. Okay, that's cool. That's cool. Now let's see the final solution. Okay, you loop over the map. Yeah, nums array. You do a num is equals to nums index. So you assign the value. You find a complement. Okay. Again, m minus n is the key value. This again reinforces that idea. And we try to put it in a map. Wait, what? This will be minus 1. Oh, this is so neat. This is neat code. That's pretty fun. So, how do I explain this? Okay. Yeah. So the idea for neat code is that they're gonna try to find the two sums. Okay. So they'll iterate over the array. So 0, 1, 2, 3, 4, 5. Okay. And if they find the two sum, okay, they're gonna check if it exists in the map. If it does not, it just assigns it to the map. So we have the same loop which for use for assigning to the map, use for checking the map, which is pretty intuitive to be fair, intuitive to be fair, where we're using the same loop to iterate the map and to assign to the map. And if the values are there, then yeah, we just return it. Pretty very beautiful. Okay, so now come back to our main question. The idea of m minus n is pretty nice. Do you think this is the pattern for two sum? Okay, let's just try to open Anki and try to think of um and hmm, okay. So two sum. We'll put it in DSA algorithm. Okay, you know what? One thing which we can try to do to see the YouTube video and see if the Tusum has also made a nice
Let's solve LeetCode
image and
1 2sum, the most popular LeetCode question. So we're given an input arrays that sum to the target, and we want to return their indices with first value. And that sum of a value free value in this array. Now let's check like then. I'm going to say the index is I. Example now the thing to notice is that for each number, for example 1, the value we're looking for is the difference between the target and this value 1. So we're looking for 4 minus 1, which is equal to 3. So that means this is the only value we can add to 1 that'll equal the target. So we don't have to check every number, we just want to know if 3 exists. Now the easiest way we can do this, the most efficient, is by making a hash map of every value in our input array so we can instantly check if the value 3 exists. Now let's try the same problem except let's use a hash map this time. Now in our hash map, we're going to be mapping each value to the index of each value. So the index of 2 is 0, the index of 1 is 1, the index of 5 is 2, the index of 3 is 3. So in our hash map, we're going to be mapping the value to the index. Now we could add every value in this array into the hash map before we start iterating through it, but there's actually an easier way to do it. If we added the entire array into the hash map initially, then we would get to the value 2 first, right? We would want to check, does the difference between target 4 minus this value 2, which is equal to 2, exists in our hash map. And we would find that 2 does exist in our hash map, but we're not allowed to reuse the same one, right? Because they're both at the same index. We can't use the same value twice, so we would have to compare the index of our current 2
okay.
with the
So
index of the 2 that's in our...
here's a mistake that I did. Okay, so both me and Neat Code arrived on the same issue where we have a value which is if it's added onto itself, it gives us a target, right? So 2 plus 2 gives us 4. So if we try to do map dot get uh, target minus 2, which is 2, it will give us the same value itself, which is not allowed, right? Our output cannot have duplicates. So the way I handled it was adding additional variable, which is called dupes, and making and kind of playing around with that dupes variable to keep track of the duplicate. What NeetCode did, which is like what I think you guys should do, is simply to have two pointers. One pointer toward the value and one pointer which is like every value except the primary value. So there's a pointer which is pointing to 2 and then there's a pointer which is pointing to the rest of the array. If you do the two pointer method here, it's not really two pointer. It's kind of is, but it prevents us to have the duplicate because our result has to be the two pointers and the pointers cannot fall on itself because the way we're running the loop where we have the index and then we have the next index as index plus one, so the two pointers cannot be on the same element. This is an idea that I want to kind of incorporate, so let's see if there is a idea or like a slide picture which we can kind of think of.
Our hash map is E, so index of find it minus 5, 2. Now the reason some, if we get to the second value, our hash map is going to be this portion. Find the solution.
Okay, so I think there is not an infographic that we can use, but we can simply just write in our thing. Uh, do not, we'll have bold. I don't know if this works actually. Okay, you know what? I think I wanna rephrase this card into bullet points. So let's just have bullet points, right? Um, yeah. So first thing is first. If target is equals to m plus n, where m and n are two different values on the array, then loop over the array to find m is equals to target minus n, where n is our first pointer. Okay, so this is the first idea that we have. And instead of having like this, let's just add the link so that it's kind of a bit more fun, you know. Let's just see. Can I add a link? I can add a picture, audio, or video. Bold text, fields, front, back. Mm, add link to the lead code. No, I'm not sure how do I play with the fields actually. No, okay. Hmm. I'm sorry, guys. I think I was being quiet for a long time, so uh, I'm just trying to kind of play around to see if this works. So now, uh, I think I think this is a bit boring stream, but okay, fine. So what I'm going to do is just kind of make this a bit more beautiful. So let's do points, and it should work unless I need this to be inside. Uh, okay. Oh no, just need to do this. Okay, okay. Save, and this should be a sub point because this is not that important, but it's kind of important. So let's just have okay. A second point is that use two pointers to avoid duplicates and where m is equals to n. Okay, I think these are the two main points where which kind of are important. Okay, so now this is what I think is a good Anki card where I have the points which kind of construct a good answer solution, right? So, because like our solution is also kind of good, except the two pointer method. So these are like the couple of points. So one is like the identifying pattern. So identifying pattern. slash trick. Then this is reduce time complexity, and this is space complexity. So I think this is a good template for now, where we have an identifying pattern slash trick, which kind of like sums up a very key element of this of the problem. And then we have a space complexity point, which kind of allows us to think about how can we efficiently manage space when solving the problem. So two pointer is much better because in this case, like I don't have to use this dupes variable. I don't have to use this target variable. It's like it's a bit simpler, right? I'm using less space in real memory. And the time complexity is, of course, like the best way to conserve time complexity. If we use just TRA, we have to use that brute force method. So, and then we have like a simple snippet of the best solution. So I think this is kind of working. I'm not super sure, but yeah, I think this is a nice template. I wonder if I can just save this template. Oh, you know what I can do? And then I have space complexity, time complexity was genius. Okay, let's just see the spelling of ingenious. Um, solution. And can I move this part? Save. And okay, what the fuck? So we're creating an unordered list. Wait. Um, you know what? This is a bit boring for you guys. I think I'm gonna just stop the stream today. Um, oh my God. You guys, I was not sharing the screen where I'm editing the HTML for the code itself. So, okay, that's all right. Um, I'm gonna make it a bit better next time. But I think we're onto something. I think we have found a template for identifying the solutions, and I think we just gotta pick up the steam. We just gotta kind of grind out as many problems as we can a day. Maybe I'll stream multiple times in a day, not just like once in a long sitting. Uh, and yeah, I think yeah, it's fine. Anyway, thanks for coming for today. I'll see you guys tomorrow. Bye bye.